3 million years ago, a small ape-like creature was walking across the plains of East Africa. Its brain was barely bigger than a chimpanzee's. It had no language, no fire, no tools worth mentioning. If you placed a bet back then on which species would end up building rockets, splitting atoms, and mapping its own DNA, you would not have picked this one. And yet, here we are. Not the strongest species, not the fastest, not even close to the best at seeing, smelling, or hearing, but somehow the species that runs the planet. So what happened? How did a 1.3 kilogram lump of fat and protein inside our skulls turn into the most powerful information processing machine in the known universe? Let's dig into the strange, violent, accidental story of how the human brain got so smart. Let's rewind. About 3 to 4 million years ago, our ancestors, species like Australopithecus, had brains around 400 to 500 cubic centimeters. That's roughly the size of a modern chimpanzee's brain. For millions of years, brain size barely budged. Then, starting around 2 million years ago, something changed. With the rise of Homo habilis and Homo erectus, brain size began climbing, and climbing fast, in evolutionary terms. By the time Homo erectus was walking around 1.5 million years ago, brains had nearly doubled to around 900 cubic centimeters. By the time Homo sapiens showed up roughly 300,000 years ago, our brains had ballooned to about 1,350 cubic centimeters on average. That's a tripling in size over a few million years, an almost unheard of pace in evolutionary terms. But here's the catch. Size alone doesn't explain intelligence. Elephants have bigger brains than us. Sperm whales have brains 5 times the size of ours. So something else was going on. Scientists have a few competing theories, and the truth is probably a mix of all of them. Theory 1. Diet. Around 2 million years ago, our ancestors started eating more meat and, crucially, learned to cook food. Cooking does something remarkable. It pre-digests food outside the body, making calories dramatically easier to absorb. Brains are incredibly expensive organs. In modern humans, the brain is about 2% of body weight but burns roughly 20% of our daily energy. Without a calorie-dense diet, evolving a bigger brain simply wasn't affordable. Cooking may have unlocked the energy budget for a bigger brain to exist at all. Theory 2. The social brain hypothesis. Primates that live in larger, more complex social groups tend to have bigger brains relative to their body size. Tracking who's an ally, who's a rival, who owes who a favor, who might betray you, that's a massive cognitive workload. Some researchers argue our brains grew less to solve physics problems and more to solve each other, to navigate gossip, politics, alliances, and betrayal. Theory 3. Climate instability. East Africa during this period was going through wild swings between wet and dry periods. A brain that's flexible, one that can solve new problems on the fly rather than relying on fixed instincts, is a huge advantage when your environment keeps changing the rules. The likely truth, these fed into each other. Better diets funded bigger brains. Bigger brains enabled more complex social groups. Complex social groups rewarded intelligence. Climate chaos punished anyone who couldn't adapt. It was a feedback loop, not a single cause. Here's where it gets really interesting. If size were everything, whales and elephants would rule Earth. What actually set humans apart is organization. Human brains have an unusually large and densely folded prefrontal cortex, the region behind your forehead responsible for planning, impulse control, abstract reasoning, and imagining the future. Proportionally, our prefrontal cortex is larger than that of almost any other animal. We also evolved highly specialized regions for language, areas named after the scientists who discovered them, involved in producing and understanding speech. No other species on Earth has anything close to this level of specialization for symbolic communication. And then there's connectivity. The human brain isn't just bigger, its neurons are wired together in extraordinarily dense networks, allowing different regions to talk to each other rapidly. Some researchers compare it to the difference between a small town's phone network and a global fiber optic internet. It's not just more computers, it's a fundamentally better network connecting them. Here's the twist most people miss. The biggest leap in human intelligence didn't happen inside individual brains. It happened between them. Humans are exceptional at something called cumulative culture, the ability to learn from others, improve on what we learn, and pass the improved version on. A chimpanzee can learn to crack nuts with a stone, but chimpanzees don't build on each other's nut cracking techniques generation after generation. Humans do exactly that with everything. This is why a single human, dropped alone into the wilderness with no prior knowledge, is remarkably unimpressive. We don't outcompete other species individually, we outcompete them collectively. Every technology you've ever used, language, agriculture, writing, mathematics, the device you're watching this on, key, is the accumulated output of thousands of generations of human minds building on each other. Some researchers now argue that human intelligence isn't really located in any one skull. It's distributed across networks of brains, connected through language and culture, accumulating knowledge no single person could ever discover alone. In a very real sense, human intelligence became a collective, ongoing project the moment we developed language sophisticated enough to preserve and transmit ideas. None of this came free. Big brains are expensive and dangerous. Human childbirth is uniquely difficult and risky compared to almost every other species, largely because our heads are so large relative to the birth canal. Evolution's workaround was to make human babies extremely underdeveloped at birth, helpless for years, so the skull could still fit through, with most brain growth happening after birth instead of before. That's also why humans have such a long childhood compared to other animals. Years of dependency, protection, and learning were the price we paid for building the most complex processing system in the biological world. So, how did we become the smartest species on Earth? Not through one clean mechanism, but through a perfect storm. A calorie-rich diet that could fund an expensive organ. Social pressures that rewarded cooperation and manipulation in equal measure. A climate chaotic enough to punish rigid thinking. And, most importantly, the discovery that knowledge could outlive the mind that created it. Our brains didn't just get bigger, they got wired for connection. To each other. Across generations. Across millennia. That network is still running right now. You watching this video, thinking about ideas some scientists wrote down decades ago, is that same 3 million-year-old project still in progress. If this blew your mind, subscribe, because next time we're covering what happens when that same brain starts trying to build one of its own.